A monopolist is the only producer of a product for which there is no close substitute. Monopolists are able to maintain profits in the long run due to high barriers to entry. Recall that in perfect competition, the firm takes the market price as given. It is a price taker. If the perfectly competitive firm increases its price above the going market price, it will not sell anything. This is because there are many firms producing a product that is a perfect substitute to the firm's product. However, the firm can sell as much as it wants at the going market price. This implies that the demand for the firm's product is perfectly elastic. Since with each additional unit that the firm sells, the firm gets the market price, the firm's marginal revenue is equal to the market price. That is, the additional revenue for each additional unit of output it sells is equal to the market price. How can a firm tell if it has market power? When a firm's product is differentiated from other firms' products, the firm can generally raise its price without losing all of its customers. To sell more, the firm must lower its price. This implies that the demand curve slopes down. It is no longer perfectly elastic. The blue area represents the total revenue when the firm is charging a price of $9 and is producing 1 unit of output. The total revenue equals 9. If in the following week the firm wants to sell 2 units, it will have to lower its price to $8. Now the firm's total revenue is $16. This total revenue is represented by the area of the green rectangle. This implies that the total revenue increased by 7, which is less than the market price. Recall that the marginal revenue is the additional revenue from producing an additional unit of output. The reason the marginal revenue is less than the market price is because to sell more, the firm has to lower its price on all of the units it sells, not just the last unit. Suppose the next week the firm wants to sell 1 more unit. To do this, the firm must lower the price to $7. Now the firm's total revenue is $21. This is represented by the area of the orange rectangle. The marginal revenue is $5, which again is less than the price of $7. Again, this is because to sell more, the firm had to lower its price on all of the units it sells, not just the last one. So now the firm sells the first 2 units for $1 less than it did before, and then sells 1 additional unit for $7. On net, the firm's additional revenue is just $5. When the firm lowers its price from $8 to $7, it adds the magenta area to its total revenue. This area is equal to the price of the 3rd unit of output. This is the effect on revenue of selling 1 more unit of output. The red area represents a loss in total revenue the firm incurs from lowering its price on the units the firm was already selling. This area is equal to 2, $1 for each of the 2 units the firm had been selling for $8 before the price decrease. So putting this together, the firm's marginal revenue from the 3rd unit of output is $5. It sold 1 more unit for $7 and sold units 1 and 2 for $1 less each than it had done before. So for a firm with market power, the marginal revenue will be less than the price charged because to sell more, the firm has to lower its price. To better understand why it is that marginal revenue is less than price and how to actually graph the marginal revenue curve, consider the following. When the firm's demand curve is linear, the firm's inverse demand curve can be given by equation 1. By inverse demand, we mean when it is written with P on the left-hand side. Normally, we write the equation with A and B as specific numbers. Total revenue is equal to price times quantity. This is equation 2. If we take equation 1 and substitute it in for P in equation 2, we get equation 3. Multiplying through by Q gives us equation 4. This shows how total revenue changes by quantity. If you graph it as a function of Q, it is a hill. Now here is the cool part. Marginal revenue is the change in total revenue divided by the change in Q. In other words, marginal revenue is the slope or the derivative of total revenue with respect to Q. Taking the derivative, you get equation 5. This is the equation for marginal revenue. It has the same intercept on the price axis as the demand curve, but is twice as steep. Here is the graph. The marginal revenue curve has the same intercept, but is twice as steep as the demand curve. Marginal revenue is the slope of total revenue. When total revenue is maximized, the slope of total revenue is 0. In other words, marginal revenue is 0. You will recall from the chapter on elasticity that when total revenue is maximized, price elasticity of demand is unit elastic. We also learned that in the lower portion of the demand curve, price elasticity of demand is inelastic. And in the upper portion of the demand curve, price elasticity of demand is elastic. Now let's add the cost curves to the picture so that we can figure out how much the monopolist will produce to maximize profit. Recall that profit is equal to total revenue minus total cost. In the lower graph, profit is maximized where total revenue and total cost are furthest apart. We will label this point as Q star. At this point, the slope of total revenue is equal to the slope of total cost. Since the slope of total revenue is marginal revenue and the slope of total cost is marginal cost, at this point where profit is maximized, marginal revenue equals marginal cost. At the profit maximizing quantity, the firm will charge P star. At this point where profit is maximized, the price elasticity of demand is relatively elastic. The profit maximizing monopolist will never price in the inelastic portion of the demand curve. If price elasticity of demand is inelastic, then increasing price will increase both revenue and profit. Another interesting insight from this analysis is that when the firm is maximizing profit, it is not maximizing total revenue. If the firm is at the profit maximizing point Q star and decides to produce more, then total costs increase faster than the total revenue increases. This is another way to say that marginal cost is greater than marginal revenue. So profit is maximized at the point where marginal revenue is equal to marginal cost. For this example, this is where quantity is 4 and price is 6. When quantity equals 4, average cost also equals 4. Recall that profit can be written by this equation. Plugging in the actual numbers, we see that profit is $8. In the graph, the profit is given by the orange rectangle. Here's a refresher on why profit can be given by this equation. If we multiply through by Q, we get this. The first term of this equation is total revenue. The second term of this equation is total cost. Thus, profit is total revenue minus total cost. This is a refresher on why the area of the orange rectangle represents profit. The area of the rectangle is height times base. The height is price minus average cost, and the base is Q. The product of these two terms gives us profit. For the single price profit maximizing monopolist depicted in this graph, what is the profit maximizing quantity, profit maximizing price, and profit? 50 is the profit maximizing quantity because this is where marginal revenue equals marginal cost. If the monopolist charges a price of $95, then consumers will demand a quantity of 50. So the monopolist will charge a price of $95. The easiest way to solve for profit is to use the equation that has profit as a function of price and average cost because these are the values we are given. Plugging in for price, average cost, and quantity, we get a profit of $1,000. At the profit maximizing quantity, is demand elastic, unit elastic, or inelastic? At the profit maximizing quantity, price elasticity of demand is elastic. The monopolist always maximizes profit in the elastic portion of the demand curve.